Hello, good morning, everyone. Thank you so much for starting your day with us here on this last Friday of June, which happens to be National Safer Workplace Day. We thank you and welcome you to our webinar. My name is Devin Murray. I'm the manager of the Technical and Engineering Services Division of Schmerzel here in North America. Again, we really appreciate your time and participation, and it is my pleasure to take this time to highlight this very important topic, which we hold near and dear to our hearts, which is safety. So we have a great, uh, informative webinar for you today around a topic for risk reduction measures. If you're not completely familiar with what National Safer Workplace Day is, I have a couple of slides at the end to highlight that initiative, tell you what that's about, give you some ideas, some ways that you can participate, and then we'll send you on your way to enjoy this last Friday, which is also National Safer Workplace Day. Okay. Um, Quick housekeeping notes. This session is being recorded, so you will receive a link to download the record and share it with your colleagues if you choose to. Please feel free to use the questions field if you have any questions at all as I go over these topics. Again, for this topic is kind of a 10,000 foot overview, but if you have any questions, please use the questions field, and I'll get those at the end of the webinar. Okay. Let's look at the agenda. All right, what do we have for you today? So we're going to define this term risk reduction. Now we'll pull up a standard. We'll see what risk reduction means, and then we'll go into detail of how to apply risk reductions. And by looking at the standard, we'll look at inherently safe design measures, engineering controls, and administrative control measures. And as we look at each one of these risk reduction measures, we'll see the different ways that we can implement those. We'll go a little deeper to see how each measure can affect the risk factors. So we'll spend some time with that. And again, at the end of this webinar, I'll end off with an ending message. Look at some stats for safety, industrial safety, as well as again, what is National Safer Workplace Day? What is this initiative? Okay, so with that, let's go ahead and take a look at this information that we have today, which is the risk reduction measures. Again, we're only look at a basic level, right, for machine safety. First thing is, let's define what a risk reduction measure is, right? Or this idea of a control measure. And to do that, to get the definition, we can pull from ANSI B110, which is a standard for the safety of machinery. This standard itself is considered a type A standard, so it's a basic standard, gives us general information, terminologies for safety, right? What's the definition of a hazard? What's the definition of a risk? It gives us the guidance for an actual risk assessment. This standard itself, ANSI B110, is intended to be used with other standards, so other type B standards for particular aspects of safety, or other type C standards, which are for a specific type of machine, for example. So this is a general standard, but it gives us the definition. And the definition of a risk reduction measure is any action or means used to eliminate hazards and or reduce risks. Okay, so if we look at this uh, table here from the standard itself, we see that the first thing that you need to do is a risk assessment. Again, this webinar is not going to go over what these steps are for the risk assessment. We do have other webinars that you can find on our website that go over the risk assessment process and procedure. Again, those are 1 hour webinars. We can, of course, do full blown day webinars, but that's another discussion on the topic. Okay, but first thing is you need to do a risk assessment. After the risk assessment, then we would do the risk evaluation, risk estimation, and we have to ask ourselves this question: this hazard, this risk that you have identified, is this acceptable? Okay, is this a tolerable risk? And then if it's not, that's when we get into this idea of risk reduction measures. And based off of an ANSI 11.0, it will tell you, you know what, the first thing that you want to do, especially if you're the OEM, right, the supplier of the machine, is you want to see if you can design safety into it, right? Can we design this hazard out of this machine, out of this process? If we cannot design it out, we then look into adding some type of engineering control measures, and they have some examples here as far as guards or device and control functions. And then the last thing, as far as the OEM is concerned, right, the machine builder or the integrator, it's can we provide some information for use? And again, to give some examples, some warnings and signs. ANSI 11.0 also goes into details for the end user. Okay, so as an end user, if you're looking at a legacy piece of machinery that you have on the floor for quite some time, or in those instances where yep, we have a brand new machine, but we still need to do a risk assessment, right? We need to make sure that there are no hazards where we are installing and commissioning this machine. Anytime you change a process, change part of the machine, you have to do a risk assessment, right? So as the end user, ANSI 11.0 also gives some guidance on what you may implement to help reduce some risks. So for the end user, it looks at some additional design measures, okay, some additional engineering controls, so aftermarket interlocks, right, additional guarding that you may need to add, some awareness means, information for use, for example, trainings and procedures, relying on administrative safeguarding methods, supervision, right? Having some supervised tasks, control of energy sources, the use of hand tools, for example, and then lastly, as the end user, supplying some PPE to help reduce exposure to these identified risks. So this is the options or the guidance that's provided by ANSI 11.0, and what you typically see in your general safety trainings, right, is this hierarchy of control measures. This is where this is coming from, right? So, okay, we have a hazard, we have risk associated with this hazard. Let's see if we can eliminate, let's see if we can substitute, let's see if we can add engineering controls, or are we going to rely on administrative measures and PPE? And I always say typically what you will see is a combination of this, especially for legacy machines. We have some engineering controls, maybe aftermarket, like some interlocks, some light curtains. You still have, the administrative controls. We still have training, right? Annual training for using the machine, identifying those safety functions, and of course, if needed, some additional PPE. So it's usually a combination of these. For existing machines, it's kind of hard to eliminate a hazard that's been designed in, right? And it may be kind of hard to substitute a hazard that's been, again, designed in. This is why we start the risk assessment process, though, at the design phase, right? Because if we have these discussions at the design phase, we have a higher chance of being able to eliminate and substitute those hazards that have been identified. Okay, but this hierarchy of control measures is being developed from this ANSI 11 or even ISO 12100 guidance for risk reduction measures. What I want to do is spend some time to look at these individual risk reduction measures, starting off with the first one here for inherently safe by design measures, or if you're an end user, maybe doing some redesigns. Okay, so let's look at what are some options and again how they affect certain risk factors. Okay, so first thing is let's look at what is being called out from these standards. When we look at trying to design safety in, right, inherently safe by design, the first thing we want to look at, the first topic we want to look at is being able to limit the interaction, right, or modify the process to eliminate or reduce human interaction. And it can be something like we see here as an example. Maybe there's ergonomic hazards, or maybe there's hazards with just dealing with material handling, or we want to incorporate some type of industrial robot, collaborative robot. We want to modify the process so that the operator is not spending too much time inside of the hazardous area. They're not spending too much time interacting with the dangerous parts of the machine. So let's see if we can modify the process so that we can limit or eliminate the human interaction with this machine. And if we do that, again, this is part of the design phase. We're able to say that, yes, we have an inherently safe by design piece of equipment, process, machine. Okay, so this is the first thing. Can we limit the interaction? The next one would be elimination. Can we look at this task or this hazard that we have, and can we completely eliminate it by replacing this dangerous task that we have identified, increase clearance, or maybe reduce the magnitude of the energy source. Okay, so when we look at this, for example, for increase in clearance, okay, so maybe we have a tight area where we have the possibility of maybe being crushed with equipment, okay, or maybe we don't have enough area, enough working envelope to actually do the task. Right? That is a hazard if we don't have enough area to do the task, whether that's for an operator or even maintenance tasks, right? Because let's face it, space is a premium on the plant floor, right? And we see a lot of machines kind of jammed close to each other. We have to take that into consideration when we do our risk assessment. We may identify some hazards with that. So maybe we need to increase clearance, give our employees, give the operators and technicians and maintenance personnel more room to actually work so that they can perform their tasks safely. If the energy magnitude, if it's high and that's creating a hazard, can we reduce it to a more acceptable level? Yes, we still need to make sure that the machine can operate and do its intended task, but can we do that at a lesser magnitude so that it is a safer task as well? Okay, that's the dance that we have to do, right? Can we make it safe, but we still, of course, want to make sure that we remain efficient. I mean, that's the goal. The other option here would be substitution. All right, so can we look at a hazard that's on this machine or with this process, and can we substitute it? And we have here from the standard, they mentioned having, again, an automated material handling process be substituted using less hazardous chemicals, reduced forces and speeds through inherently safe components. Okay, so the example we have here is using less hazardous chemicals. And if we have a process where, yes, part of this process does require us to use this chemical, and if we inhale this chemical, we will be exposed to these dangerous hazards, right? These dangerous potential sources of harm. Let's do some research, right? Can we perform this same task with some chemicals that are less dangerous? Okay, where maybe we don't need the additional PPE to handle this type of chemical. And let's see if we can do that. And if we do that, that is again a substitution of the first identified hazard, that dangerous hazard. Now, what I want to do is look at these individual guidance that they're providing from NCB 11.0 and see how this can affect the risk factors. And when we look at the risk factors, we're looking at the severity of injury, the exposure to these hazards that you have identified. We're looking at trying to be able to avoid the hazard. And we're looking at, well, what's the occurring event? Like what's going to make us be exposed to these hazards. Okay, so that occurrence of harm being by definition the probability of a personnel being exposed to the hazard and the probability of that hazard situation occurring, right? That's what we're trying to avoid. So if we look at modifying the process, replacing the task, reducing the energy magnitude, automated material handling, less hazardous chemicals, reduced force, how does that affect these factors? So if we look at the first one, if we say, you know what, let's try to modify the process, eliminate and reduce human interaction, what does that do for you? Well, if we go back to ANSI B11.0, they say, you know what, if you're able to limit interaction, you would be able possibly, okay, possibly be able to reduce exposure and reduce the occurrence of interacting or being introduced to that hazard. Okay, the severity of it will still be there because we're not eliminating, right? We're not eliminating the hazard. We're just trying to limit the interaction with this machine. So the severity that we've identified will still be there. We're not doing anything with the avoidance aspect of it. Okay, we're not adding any guarding here. We're not avoiding it. But because we are limiting the interaction, we would possibly affect the exposure and the occurrence of that hazard. Okay, now if we look at trying to implement this process here, or modifying the process to eliminate or reduce human interaction, the standard will also say, you know what can this be prone to? Like, how can this actually fail? Can this control measure fail and lead us to the hazard, or will they or can there be some error or misuse by personnel? And if we're looking at, okay, you know what, we want to modify the process, then we would be more prone to be exposed to the hazard if we were to misuse or have an error with doing any type of interaction with the equipment or the process. Okay, so we're going to look at each one of the options from the previous slide and again see how this changes. So the next one would be trying to replace the task or again increase the clearance for our working environment. Okay, so if we can do that based off ANSI B11.0, they say, you know what, if you are able to replace the task, okay, so we have one hazardous task and we replace it with something that's less hazardous, then we are possibly affecting the severity and the exposure of that initial hazard. Okay, if we are replacing this initial hazard, then it's no longer there. Okay, so we're not prone to any failures or misuse of it because it's no longer there. We would still be exposed to a hazard, right? Because there will always be some type of hazard on the machine. The goal is to make sure that the hazard is acceptable. Right? There's always going to be hazards associated with the machine. We will never have a machine or process that is free from all hazards. Right? So if that's your goal, you're going to have a very hard time getting there because we can't do that. Okay, so with this initial hazard that we have, again, let's see if we can change the severity and exposure of it by eliminating the task or increasing clearance if we can. Um, Also, or next one, elimination. So if we have a hazard that's based off energy magnitude, if we reduce it, again, ANSI B11.0 says, yeah, you know what? Possible effects on the risk factors will be the severity, okay, and occurrence. And we may be prone to a failure of the system that we have, right? Trying to eliminate these high magnitudes of energy. Okay, we look at the factors here, right? So severity of injury. Well, we can have something that's catastrophic or serious, moderate, minor. Okay. If we look at the probability of occurrence, for example, that's something that's very likely to happen, likely, unlikely to happen, or a remote chance. Right. So this is what we're looking at. Are we able to avoid the hazard? the exposure. How often are we being exposed to this hazard that we've identified? So, what can we do to affect these risk factors? All right. Because we're relying on a control function at the end of the day, right? Because we're reducing the magnitude. We're not worried about an error with misuse, but possibly a failure with the system that would lead us back to a hazardous situation. Okay. If we can substitute, all right, substitute. The first one is substitute by using an automated material handling system. We see that we can check all these boxes according to ANSI B11.0. Okay, and then we are removing the operator from this hazardous situation, this hazardous process that we've identified. So we're able to check the box for, you know what, we're going to have less severity, exposure, less avoidance, less occurrence with dealing with this hazard that's been identified. However, because we're relying on this, we may have a failure with the automated system. We may have a failure with somebody misusing the automated system. Okay, so we see that, you know what? Yes, this is great. It checks all these boxes, but oh, wait a minute, it checks all these boxes as well, right? So it all depends on what we're able to implement for these risk reduction measures. Using less hazardous chemicals. Again, we are able to affect the severity of it because we're using less dangerous chemicals, but we are prone to misuse and errors from that individual, right? That personnel using the chemicals. It is still a dangerous chemical, right? The thing here is less hazardous, right? Last one is substitution. And again, we have here reduced force and speeds, etc., through selection of inherently safe components. If we're able to use safe components, the factors that we may be able to affect will be severity and avoidance. All right. If we're using inherently safe components designed to fail to safe, design properly, inspect for the again process or machine, according to ANSI B 11.0, we're not prone to failures with the system or misuse because it's inherently safe by design. Okay. Next one. Next section. Engineering controls. Okay. So if we can't eliminate and substitute these hazards that we've identified, let's see if we can add some engineering control measures. And we're not going to go into the weeds here with this as far as the safety circuits are concerned and categories and performance levels and how we wire things up. Again, we want to stay at a high level and just look at these individual options for engineering controls. Okay, and again, what are we doing with those hazards that we've identified as we try to apply these engineering controls? Okay, so with that, if we go back to our ANSI B 11.0, it says, you know what? If we are looking at a machine, again, we can't substitute, we can't eliminate, especially, I say, especially for these machines that we already have. Okay, they've been designed, they've been installed, and in some cases, they've been installed for 20 years, right? We can't eliminate the hazard, we can't substitute the hazard. So let's see what we can do to minimize exposure to these hazards. So the first thing is, you know what? Let's see if we can add some guarding, right? So whether it's fixed guards or shields. All right, this is an engineering control. And I always say, when I do the training, start off with this, right? Because if you start off with using fixed guards and shields and hard guards, we're not tying into any safety systems, right? Again, especially if we have an existing machine that's been running for 5 years, 10 years, 15 years. If we can avoid opening up that can of worms, right? Which is either controls and trying to tap in these new technologies into these old logic systems. Let's see if we can implement safety with this measure first, right? So let's see if we can add some fixed guards or shields. Okay. Now, in most cases, even when we are able to use fixed guards and shields, we tend to see that, you know what, yeah, we still need some type of interaction with this machine. We have to open up a guard, right, to take a sample, place a part, remove a part, whatever the case is. With that, then we look into a movable guard. All right, and when we look at these fixed guards and shields, yes, there's more things we need to take into consideration. The type of guard, the right height, the right distance. That is another conversation. But this one is, what are those engineering control measures? If we say, you know what, yep, we have a guard that can move, we then need to place some interlock devices on there so that the machine knows that the guard is open. Okay, or presence sensing devices such as a laser scanner or a light curtain, so that when we interrupt or walk through or reach through these devices, the process goes to a safe state, right? The machine goes to a safe state. We have a safe condition. When we look at some other tasks, maybe with perhaps maintenance, right? Some setup tasks, we need to make sure that we can control the hazardous motion, right? And ANSI 11.0 says here are some options to help control the hazardous motion, maybe with the two-hand control module or an enabling device, right? Whether it's with your hand or depending on the task, if you need both hands, maybe you can use a foot pedal for an enable device. Okay, now remember here, the hazard is there, right? We've already came to the conclusion that this is the hazards that are with the machine. There's nothing we can do as far as eliminating or substituting them. So these tasks or these options that we have here are how can we safeguard these identified hazards, right? So again, guards, interlock devices, or safety functions, right? These are engineering controls with these types of devices. Also, for engineering controls, ANSI 11.0 says, how about if you can't do the previous ones, maybe, or in addition, doing some type of restriction, right? So control selection of operating modes. So maybe we can have a keyed selector switch, right, to go into the different modes of the machine. Again, there's things that we need to consider as well. So if we are using keyed selector options, we need to make sure that the keyed is controlled access. Okay, because that defeats the entire purpose if we leave the key inside of the operating modes, because then anybody can change the operating modes. We want to see maybe if we can monitor or limit the hazards by using some monitoring for speeds and forces. Okay, and I see a lot of times where there's this a process where there's a task associated with it, maybe setup perhaps, and okay, fine, we go into setup mode and we see that there is a slow speed now on the machine. All right, and this is great. The thing is, this is a great start because we need to make sure that it's tied back to safety, right? Because if we have a speed that's being reduced, we want to make sure that if for any reason that speed goes beyond the intended speed for this task, that we have a safe shutdown. So we want to make sure that these speeds are being monitored safely, that these forces are being monitored safely, right? And that can be done with safety monitoring devices. Okay, um, emergency action. Again, the hazard is there. How can we bring the machine to a safe state? In the event of emergency, we look into emergency stop devices, whether it's with the traditional e-stop palm button or a cable pull switch, depending on the process, depending on the machine, right? Instead of having multiple e-stops down an entire line of a conveyor, you can use something like an emergency cable pull switch. Okay, so these are some risk reduction measures for engineering controls. Great. How does each one of these affect the possible risk factors? Okay, and again, there are individual standards for each one of these options that you would want to dive into once you decide which engineering control method you want to use. For the purpose of this conversation, for this webinar, it's just here are the risk reduction measures, and here are some things you want to take into account as far as the risk factors, right? So if we are able to utilize fixed guards, okay, and maybe some safety functions with guard door interlocks and presence sensing devices, we see, you know what, we're not affecting the severity and avoidance, right? Again, the hazard is still there, but as far as exposure and the current events, we want to make sure that by the time we open up a guard door or reach through a light curtain, we want to make sure that we can't easily reach over or through a guard. We're going to have the effect that, you know what, the exposure, we can check that box. Right? The occurring event, we can check that box. However, we may be prone to failure and misuse, okay? Because we can take a safety function and wire it incorrectly, right? You can, program an incorrect program for safety POC. Right? You can maybe remove a guard if we're not using the right type of fasteners, okay? So between misuse of the operator, perhaps, or failure with the system. Okay, maybe you need a two-channel system and you design a single channel system where if there is one failure with the channel, you lose the safety system. Again, that's conversation for another day. Okay, but again, we want to make sure that you understand that there's always more that we have to consider than what we just list here for this webinar. Okay, using two-hand controls to control the hazardous motion, right? So now we are relying on this safety function for, in this case, maybe an operator to trigger a machine start. Okay, so with that, again, that hazard is still there. We're not designing it out, so it's still there. But with two-hand controls, we're able to say, you know what, we are minimizing exposure, avoidance, and occurrence with with this hazard and the personnel. But again, it's a safety function. When there's a will, there's a way. Let's be honest. So there may be some misuse, but even if there's no, willful intent, maybe just some errors that can happen when trying to use a two-hand controls. And again, maybe it's possible failures with this system. Okay, and this is where some other standards come into play as far as trying to minimize failures with the safety system. Man, that's when you start to get into the conversation for categories and performance levels and SIL ratings, things like that. But 10,000 foot view, looking at a safety function, it's prone to possible failures and misuse. Okay, for enabled devices, we say, you know what, avoidance and occurrence. Not we, but ANSI B11 says that, we can check the boxes for avoidance and occurrence. Okay. Again, there's different options for the enabled device as far as two functions or three functions. Same thing for the foot pedal. Depends on the application, what you're trying to do for the process. Well tried principles. It all depends. And again, there's more standards that we have to consider. Like for the two-hand controls, for example, we want to make sure, or we have to make sure, that we are tying those back to an anti-tie-down monitoring device, right? To make sure that it is a true two-hand function. Okay. Same thing for the e-stops. Yep. Yes, we want to apply, an e-stop. Well, we'll get there. I won't jump ahead. For this one, for restricted operations, control selection of the operating modes, we are relying on, yes, it's a key safety function, right? So maybe some errors and misuse, and if we treat it as a safety function, the severity is still there. Exposure and avoidance, we're really not changing because we're relying on this key function, but we can possibly reduce the occurring events. Okay, so that initial hazard and setup mode. Okay, we have all these hazards that are identified, and yes, we'll look into safe speed monitoring and control of hazard energy or control of motion, not to say with enabled devices. But how do we even get into that setup mode? Well, we can rely on this key option, and that only affects the occurring events. Okay, so maybe we need to do a combination of these. Again, some more things to consider. Right? Not just a one, may not be just a one option we can check, and then we're good, all good for this entire process or entire machine. We may have to do a combination of these. Okay. Maybe we want to look into monitoring or limiting the speed and forces. Right. Maybe we have a collaborative robot, right? And maybe we say, you know what? Yeah, this is perfect for us. We want to have the same working envelope as the operator. We need to make sure that the speeds and forces and pressures are at an acceptable level based off of that risk assessment, right? For that collaborative application, I should say. The emergency stop functions. Okay, again, there's standards for this. There's standards if we're looking at a collaborative application, right? There's standards to help us determine what are appropriate speeds and forces. For e-stops, there are standards to let us know what an e-stop function has to have, right? Red mushroom, mellow background, self-latching, manual reset, remove all hazard energy. Okay, so there's other standards that we have to consider if we're selecting these certain options. Okay, because we are doing a monitoring, possibly limiting the speeds and forces of these hazardous speeds and hazardous forces, because we are eliminating these hazard energy by the use of an emergency action. We now see from NTP 11.0, you know what? We may be able to have an effect on the severity of the hazard, especially with this, right? If we're limiting that force or pressure or speed with that hazard. Okay, again, looking at a safety function at the end of the day, so there's that chance of a failure happening. And we take more into consideration with the right category and performance level. Okay, the last one, administrative controls. All right, and yes, this is on our hierarchy of control measures as far as what we can do to help minimize exposure to these hazards. We just can't jump to administrative controls, right? So we can't go through our risk assessment and say, yep, we have this hazard that is defined as catastrophic and very likely to happen. So it's a high risk hazard. Let's go ahead and throw some signs and some warning markings on there. Yeah, no, that's not how we do it, right? So we have to go through the hierarchy of control measures, right? Elimination, substitution, engineering controls before we get to administrative controls. And again, what you see is kind of a mix and match of a few of these, typically on a machine, right? But for administrative controls, the awareness means we may be able to implement awareness barriers and signals and signs and markings as we see here. Information for use, right? So if you are an OEM designing the machine, trying to have these quote unquote administrative controls, you add some guidance on how to properly use the machine safely, how to perform a process safely if you're an end user, right? You take that information as well, tie it into your safe working procedures, into your trainings, right? Of course, you're going to do your job safe analysis to see what else you may need to implement for your administrative controls, safe holding, safeguarding method, perhaps. Okay, where we're looking at essentially a method that's going to prevent contact with a hazardous area or hazardous point of operation. Okay, so this idea of safe holding, it involves implementing procedures to make sure that we're minimizing risk of injury. So it's not a physical barrier like what we saw previously in like a guard, but rather it's a set of instructions or practices to help keep maybe the hands free from the point of operation. Right? So the idea of safe holding. How do we properly hold this part as we bring it to a grinder? Right? How do we properly hold this part as we take it to a saw? Right? But that is purely an administrative control. Right? That's part of the training. How do we properly hold these parts? Okay. What else do we have? Administrative controls, supervision. All right, so supervisory control of configurable elements. All right, so maybe this idea of we have a safety PLC, okay, and well, we want to make sure that those options to configure are locked, and only we can only access those with, of course, pins and passwords, right? Things like that. Um, but even if we're not looking into, a full-blown safety PLC, right? Because then you need to go to the control panel, you need a laptop. There may be certain functions that may be easily changeable on the HMI. Okay, maybe certain speeds can be changed. Where maybe we don't want the operator to adjust these speeds, because then that will bring in possibly some additional hazards that we need to take into account for. So things like that. If it's something that we can configure, but it may introduce these hazards, then we have some supervisory control of these configurable elements. That's what they mean by that. Isolation of hazardous energy, right? So maybe bringing in this idea, right? A whole nother topic, right? A whole nother discussion of lockout, tag out, right? There's a whole set of procedures, a whole program that we need to follow. But for administrative controls and dealing with this machine and the process, maybe we may rely on isolation of hazardous energy. Last two here for administrative controls would be hand tools. Again, keeping our hands, our own hands, or operating hands outside of this point of operation, using some additional hand tools to make the task a little safer. And then the last thing, the very last thing that we can do is rely on PPE, right? Whatever that may be, based off of the hazards and tasks that we've identified. Right? Even with the administrative controls, I already said it, but you're going to see a mix and match. If we look at engineering controls, um, PPE, right? If we're using hand tools, there's still going to be PPE probably involved in training. Training is logged, training is annual. Okay. Maybe based off of the task that we have with the equipment, maybe we have controlled access to the area or controlled access of that machine. So that there's maybe quite a few different administrative controls that we can add to make sure that we are providing the safe machine, the safe process, the safe task. And just like we did for the other risk reduction measures, we'll go quickly to look at these awareness barriers. What can this possibly affect from our risk factors, right? Exposure, avoidance, and occurrence with the proper implemented barrier, right? So not the yellow safety chain that do not enter, right? We're not talking about those. And again, even if we look at this, right, 10,000-foot view, we say no awareness means, oh, we can check these boxes. Sounds great. Yeah, but did you already try to do engineering controls, right? You have to go through the process and you have to exhaust the previous options, right? And of course, you have to document, you have to justify, right? You have to justify why didn't you do some fixed guardings? Why didn't you do movable guards with interlocks? How come you didn't add any safety functions like the light curtains and safety mats and scanners? Why are you relying on just awareness barriers? Okay, and it can't be for costs, right? That is not a justification, right? Oh, just cost and easy just to add the awareness barrier. Good luck trying to have that justification, right, with an OSHA inspector. Okay, so yes, this is on the list. It is an option. It is an option once we've exhausted all previous guidance. Okay, and that's with everything within this administrative controls options here, right? Um, Awareness signals, letting people know that there's a hazard here. Okay, you're approaching the hazard, because that maybe that would affect the avoidance in a current event, because we are making people aware that they are approaching a hazard, right? Again, maybe utilizing some additional control measures, maybe something like safety function with a scanner that's using a warning zone and a hazardous zone, right? Again, can we do that first before we rely on just a light that there's a hazard here? For awareness means information for use. safe holding for parts when interacting with the point of operation, the supervisory controls of configurable elements. I have this all listed on one slide because when we look at these factors here, they all check the same box. Right? So we don't have to go over 4 different slides. So here, if we do the awareness signs and trainings and safe holding and supervision, then we can, according to ANSI 11, say, yep, we can do avoidance, deterrence. And as you would imagine, right, looking at these administrative controls, this is highly prone for misuse and error. Okay, we are not looking at safety functions that would fail to safe. We're relying on process, right? Training procedures for individuals to make sure that they are properly implementing these control measures, right? And this is why we just can't jump to this. Okay, control the hazardous energy. Um, we are removing hazard energy from the machine, hopefully before we do the task, right? So we're not looking at this e-stop condition, right? We said, okay, here's a task that we need to do. We need to isolate hazard energy. And by doing that with ANSI 11.0, we can check these boxes from the risk factor. Again, we're relying on the, maybe in this case, the maintenance personnel or the technician to, in this case, turn the knob, right? But we're relying on them to do this. So this is administrative control, and again, prone to errors and misuse. Tools, PPE, okay, separating people, personnel from the hazards. Again, we can put tools and PPE on the same slide because it matches or it checks the similar boxes. Okay, high level, all right, high level risk reduction measures, elimination, substitution, engineering controls, administrative controls. Again, you've probably seen that inverted triangle for the hierarchy of control measures. I've seen a lot of times where we don't go into detail or the trainings don't go into full detail with the administrative controls. And again, we didn't go too deep, right? We only have an hour, but I wanted to introduce those other factors that we may need to consider for these risk reduction measures. Okay. Um, we have additional information, of course. If there's more questions, need for clarification, feel free to reach out. We can, we can answer those questions. Again, this is being recorded. You can rewatch this, and as you rewatch it, again, if something comes up, feel free to reach out to us. Okay. Um, thank you for this part of it. All right. Again, just giving you some basic introduction or basic information for these risk reduction measures. Before I let you go, I wanted to spend a couple of minutes really quick just to talk about what today is and what this means for us. Again, you got the invitation, you signed up for this webinar, so you may know already what National Safer Workplace Day is, or maybe you said, this sounds interesting. Let me just sign up. And hopefully the information that we provided so far has been useful. So I just want to take just a minute or two to talk about what today actually is. Okay. So this SAFER is an acronym for Stop, Assess, Formulate, Execute, and Review. Okay. This is the initiative that we created 3 years ago. It is on the national calendar for the last Friday in June. And this acronym for STOP, it's to stop hazardous situations. Okay? Whether it's for a machine, it's for a process, anything that you're doing within this industrial environment. Okay, so yes, our primary focus from Schmerzel and Technicum is machine safety, but this can be applied to anything within the industrial environment, right? For any uh, industrial environment. So let's look at what we're doing. What are our tasks? Is this a dangerous task? Let's stop. Let's stop before something bad happens. All right. Because if we stop to assess, it's a whole lot easier. better as opposed to stopping because someone got injured, right? So let's take this initiative. Let's stop, see what's going on. Let's assess this process, right? This task, whatever we're doing. Let's see what we can do to make it safer, right? Once we stop and assess the situation, we can then formulate a plan. Okay, what can we do? And we may have a couple of options, right? We may look at some of those risk reduction measures we just spoke about, right? To try to formulate a plan. Once we have something in place that we want to try to make this safer, again, whatever that is, whatever it's a machine, process, task, whatever it is, what can we do to make this safer? We then try to execute it. But that's not done. We're not done yet. Once we implement it, we then have to do another review. Okay, and the main reason for this is, well, you know what? We apply this control measure, like we just spoke about, but maybe it still needs to be safer, right? Or let's face it, maybe there wasn't the best solution. Okay, maybe we tried it, and the operators and maintenance technicians they say, oh, we can't use this machine like this, right? It's not working the way we thought it would. Well, you know what? Let's go back, redesign. Okay, so this is why we have to do a review of what we implemented. Okay, this is the basis of a risk assessment, but again, we can use this for anything. Okay, really quick, some last notes here as far as the some stats for machine safety, for safety in general, right? Manufacturing employees missed an average of 75 work days due to workplace injuries. And that's according to Travelers Injury Impact Report. Okay, that's quite a few days. All right. Um, what else do we have? 3.24%. So in 2024, the maximum civil penalties were raised by 3.24% by OSHA. Okay, this was to adjust for inflation. Right, so everything's going up. Right? We see it across the board, including with OSHA violations and penalties. Here's another big number, $2.05 billion. So personnel getting caught in or compressed by equipment or objects cost employers $2.05 billion in medical expenses and lost wages. All right, this was a stat that we captured from Liberty Mutual Workplace Safety Index. It's a pretty big number. Okay. Again, let's see what we can do for safe reduction measures to help avoid these types of injuries. 15%. Okay, so about 15% of workplace injuries in the U.S. happen in manufacturing. All right, that's according to Electro IQ. So some of these stats you may have seen if you follow us on our social media. And I like to end off this webinar with this message that safety is your responsibility. It is your responsibility because if we say it's everyone's responsibility, then it turns out to be no one's responsibility, right? Because everybody says, well, somebody else to take care of it. So safety is your responsibility, and to help promote safety, right? Again, we have this initiative for National Safer Workplace Day. Um, which encourages employees to create a safe environment, right? Employees to participate in safety measures, and as start off your day, if you're starting off your day, or I don't know if you're second shift, third shift, whatever the case may be, but as we continue on the day and into next week, and therefore and after, we say, you know what? Let's promote National Safer Workplace Day. Let's acknowledge a coworker, right, or employee for following safe practices. Not let's not just write somebody up for doing something wrong. Let's acknowledge somebody from doing something safe, right? Identify task or process and list 3 ways to possibly make it safer. Right? You may not be able to implement those, right? Of course, there's maybe a budget maybe that we need to consider, but think of 3 things that may make it safer because you never know. Maybe it's something that it's a procedure, a process that you can implement today to make it safer, right? To save someone's life. Share your safety initiative, whether it's internally, right, or if it's to the world, right? What did you do? What did your company do to promote safety, to make sure that you are fostering this safe working environment? Okay. Um, you'll see it on social media throughout the day, whether it's LinkedIn or Facebook, Instagram, X, whatever it is. People will start using the National Safer Workplace Day hashtag. Um, Promote it, right? Again, this is an initiative to help make sure that we all remain safe and we all go back home the way that we arrived to work. And that's our goal. And that's your goal because that's why you signed up for this webinar to learn about, risk reduction measures, right? Again, we thank you. We thank you for starting your day with us. If you're starting your day with us, if you're listening to the recording, we thank you. Please help us promote this initiative. Help make sure that you stay safe, your coworkers stay safe. Thank you, everybody. Enjoy the day, and I'm happy National Safer Workplace Day. Thank you.